Thank you for that introduction. So once again, I'm James Eaves. I'm an agricultural economist and professor at Laval University in the business school. A few years ago, I started a research project with the university in two companies, Greenseal Cannabis Company and VoltServer. And following that experiment, I worked as Greenseal's head of R&D for nearly 2 years. And then last week, in fact, I joined. I left Greenseal at the beginning of the year, and last week I joined VoltServer as their indoor agricultural director. So I just for the sake of transparency, I wanted to share my links with you, professional links with you. Second, I'd like to apologize. Typically, I invest more in preparing for presentations, but as you know, it's a special time. And last week, our university gave us 1 week to convert all our courses to online courses, and so I've been overwhelmed with that, and I haven't had as much time as I would have liked to practice and prepare for this presentation. So it might be a little less fluid than I would like. I'd like to begin by just sharing a perspective about the history of agriculture with you. And I say a perspective because there's lots of perspectives. And I'd like to share one with you regarding how agriculture is on this continuous, since its advent, it's on this continuous trend towards increasing amounts of control over the environment and the plant. For instance, the transition of humans going out into the wild to gather the food to actually farming, to actually creating plots of land where they grow the food they want and attempt to manipulate that environment was perhaps the single biggest increase in control that we've seen. And that period is often referred to or is referred to as the first agricultural revolution. And over time, we've seen these other kind of discrete jumps in control that have resulted in these enormous improvements in the quality of and standard of living for humanity. For instance, irrigation and the invention of greenhouses gave humans a much greater control over the environment in which the plants grew. Whereas starting in the early 20th century, the ability to actually create hybrid plants and to genetically modify plants allowed us to control how plants responded to particular environments or to enable plants to grow in environments that they wouldn't otherwise be able to. Now, at the same time, so there's this incredible value to control, you see, to being able to control the environment. But that value isn't constant across time, and it isn't constant across crops. In other words, at different periods in time, the value of being able to control our growing environment is higher or lower, just in the same way for different crops, our value for being able to control the environment or those plants adds different value. And that value greatly depends on consumer preferences. And so I'd like to give you a sense of what I mean and examples of how consumer preferences impact the value of being able to control growing environments using two examples, cut flowers and tomatoes. And there's a typo here. It's not a little flower. It should be cut flowers and tomatoes. So the cut flower industry really began in the 1600s. And at the time, there were three main varieties of flowers. And they were grown in North America and Northern Europe, which aren't necessarily ideal environments for growing flowers. So during this period, greenhouses really flourished as the main technology for growing these flowers. But something important happened in the 20th century, in the beginning of the 20th century, was the invention of refrigerated trucks and ships. And what that allowed people to do is actually grow those flowers pretty much anywhere in the world and then ship them to the markets. So at that point, these flowers just grew, this production just shifted to parts of the world that had these kind of ideal environments for growing any one of those three varieties for the lowest unit cost of production. So for Europe, the European market, the cultivation generally shifted to Africa. And in the US, it first shifted out west from the East Coast of the United States, first to Colorado and then to California. And then when trade routes opened up, or certain trade negotiations established, that production shifted to South America. Now, but there's this interesting trend that always happens for products in like free market or capitalist societies, is that consumers generally always look for new experiences, new product and service experiences. We see that with cars, with cereals, we see it with everything. And the same thing happened with flowers. Rather than essentially consumers got bored with carnations and bouquets of carnations and roses, and they wanted more variety. For instance, today, there are at least 60 different types of varieties of cut flowers demanded by consumers. And consumer producers, of course, had to respond to that demand for variety and variety in experiences and variety in flowers by producing those flowers. But each of these flowers, or many of these flowers, demand or require different types of environments. Right? So it was easier, more cost-effective to provide those environments in greenhouses, where it was easier to control the humidity or the temperature or the amount of light that these plants received. So when this specialty cut flower market evolved, it reinvigorated the greenhouse market. And so we saw greenhouses growing flowers again in places like Amsterdam and California. And we saw a very similar pattern with tomatoes. People are often surprised to hear that California, which is one of the most important producers of tomatoes in the world, actually imports tomatoes from Canada. If you know anything about tomatoes, it's really surprising, because tomatoes are a plant that likes warm environments, and one of the most light, and one of the crops that demand the most amount of light, whereas Canada is typically cold and has relatively little light compared to other parts of the world. But what happened was, we saw a similar trend that we saw with flowers. Before the 1980s, there were a small number of varieties of tomatoes that consumers demanded. But during the 80s, the whole heirloom tomato trend started, and suddenly consumers discovered, wow, these are like there's more variety in the sort of the taste experience with tomatoes, and so they started demanding an increasing number of varieties of tomatoes. So it became profitable, right, to start growing tomatoes in greenhouses, where I could create all these different environments to optimally produce these different varieties of tomatoes. And there was no reason why greenhouses wouldn't function in California. There's plenty of light, and they could take advantage of that light and create these different environments in California. But control also requires energy. It requires electricity. Even in California, to grow tomatoes year-round, you would have to supplement the light with electric light, and electric lighting. You would have to use electricity to try to modify the environment. But because of electricity regulation in California, electricity prices are really high, whereas in Canada, electricity prices are relatively low. And so production of tomatoes, of those these specialty varieties shifted to the place where it was most cost effective to basically buy that control, right? Sophisticated greenhouses that had supplemental lighting. And today, if you look at California, 90% of tomatoes are grown outdoors and less than 10% are grown in greenhouses, whereas exactly the opposite is true in Canada. 90% of tomatoes are grown indoors in greenhouses and 10% are grown outdoors. And today, Canada, I think, is the most important exporter of tomatoes in North America. At the same time, these greenhouses still have challenges with control. For instance, this is a quote from a large ornamental grower who says that we have so many crops, we have so many different varieties we have to produce, and each of those varieties require a different environment. And our biggest challenge is customizing the environment for those various varieties. So what I just want to gain from this sort of historical perspective is the fact that when we look across markets, right, like the markets for fruits and vegetables, or when the demand for variety is low, we see that it's worth it. Like if the market only demands 3 types of tomatoes or 3 types of flowers, if it's possible to trade and ship those produce, which it is, we'll just look across the world, find the least expensive, ideal environment to grow these things, grow them at scale, and ship them where we ship them. But when demand is high and consumers want to try a different tomato every week or have different types of bouquets of flowers, then the value of control increases significantly, and you'll see farmers should be making investments into technology that enables them to customize environments and change those environments as demand shifts rapidly for each of those varieties. Now, so what does it have to do with cannabis? There's this really fascinating real-world experiment that's happening in the world of agriculture, centered on cannabis right now. For the first time in history, you see 2 types of technologies for growing a plant in a controlled environment, essentially competing. We have greenhouses, right, and simultaneously next to them we have indoor farms. Greenhouse growers are making the bet that the amount of control you with a greenhouse is enough, given that they can offset their electricity costs by replacing at least some artificial light with sunlight. Right? They're making the bet that a greenhouse is the most profitable strategy, given those 2 factors. Whereas indoor farmers are making the bet that the market will put a sufficient value on control, right, that actually growing in an indoor environment where I can have significantly higher levels of control over the environment is the most profitable strategy. Now, I'm not, just as it stands, it's not clear, even though I've been talking about the value of control, it's quite possible that the indoor farm is just too much too early, and that given the price of lights and price of electricity and price of equipment, the market's not ready to pay for that level of control. Again, it's going to depend on consumers' demand for the cost of that equipment, of course, what's the additional value in terms of the quantity and quality of the product that I produce, what's the additional what's additional value that I can produce with this increase in control. And the fact is, I would say, for being involved in this industry for a long time, that the vast majority of people in this industry think that it's a no-brainer, that indoor growing is just an artifact of the illegal market or prohibition, when growers basically had to hide their farms. And that now that growers can grow out in the open, it makes perfect sense that they would reduce their variable costs by leveraging the quote unquote free value or free energy from the sun. These are quotes from a 2017 special edition of Marijuana Business Magazine. And essentially every single expert interviewed for that article agreed that it's just a matter of time before greenhouses supplant indoor farms. There was just, I participated in this interview also, and I was the only one that believed that it wasn't so clear, that I actually believed that indoor farms would outcompete greenhouses for the high-end cannabis market. And the reason that I felt that way, that just prior to that article, about 2 years before that article was published, a co-author and I conducted a detailed analysis comparing the profitability of growing lettuce in a greenhouse versus growing lettuce in a vertical farm in Quebec. And the reason we chose Quebec was because it's a place that has relatively little light compared to other places, and inexpensive electricity. Has some of the cheapest electricity in North America. So if growing if it wasn't more profitable to grow, or at least competitive to grow in a vertical farm in Quebec, then basically it would be nowhere in North America. And for this study, what we did is we made certain important assumptions. We assumed that light levels were the same. In other words, regardless if you're growing in a greenhouse or in an indoor farm, there was a certain level of light was achieved in both. If it was straightforward how we do in a vertical farm, we just have electric powered lighting or artificial lighting. But in the greenhouse, if we don't have enough light, the farmer would have to add additional light using supplemental lighting. And so we made that assumption that electricity is the same, but that the total amount of light, the DLI, the daily light integral, is the same. And we also assumed that the quality of the product was the same. And the way we did that is we assumed that both technologies, the indoor farm and the greenhouse, neither used an HVAC system, right? Neither had air conditioning and dehumidification. Like a typical greenhouse, the indoor farm cooled and dehumidified, managed humidity by using vents and fans, right? There's no reason, typically indoor farms don't do that, but there's no reason they can't. We could have said, oh, we forced the greenhouse to use an HVAC system. That was just a way to make an apples to apples comparison. If we don't make that assumption, then the indoor farm has a more controlled environment, which can do a higher quality product or higher yields. And so we wouldn't be able to isolate the impact of basically light, right, on sunlight on the cost structure of a greenhouse. And what we found was that because the indoor farm was well insulated and the greenhouse wasn't, and the indoor farm was able to use space more efficiently because you could stack, keep plants closer together and stack plants, have a vertical farm, have multiple levels of plants, that the greenhouse used significantly more heating energy to heat their greenhouse, and they had a higher real estate cost because they took up more space. And that made the vertical lettuce farm at least as profitable as a greenhouse in Quebec. Now, that was a pretty stunning result, and it's interesting because we used lettuce as our model, and as many of you know, lettuce does not require tremendous amounts of light. So for several months of the year, actually the light that's provided by the sun is enough to provide lettuce with the required minimum amount of light that it needs in Quebec. We talk about plants that need significantly more light, right? For instance, cannabis or tomatoes. Then the contribution of sunlight to the total amount of light that the plant needs is less, right? So the value of the sunlight declines. In other words, in California, over the entire year, the sun in a greenhouse provides 30 units, call it, of light. And the plant, that would be perfectly fine for lettuce. You would even have to shade it for lettuce. You wouldn't need any supplemental lighting. But for cannabis, say cannabis needs 50 or 60 units of light, then the sun provides a smaller proportion of the total amount of light that the plant needs. So you'd have to add supplemental light to grow the plant optimally. In other words, as the demand for light increases, the plant's demand for light increases, the relative contribution of the sun decreases. So to give you a sense, so I did a kind of back of the envelope analysis for growing cannabis in a greenhouse. And my objective here with this back of the envelope analysis was just to give you a sense of how much does using the sun decrease my electricity cost when I'm growing cannabis? Is it an enormous amount that makes it really exciting to grow cannabis in a greenhouse, or a less exciting amount? Now, in order to do this, I had to make certain assumptions. First, I assume that 65% of the sun's light actually hits the plants. In other words, some percentage of the sun is going to reflect off the surface of the glass house, the surface of the greenhouse. So I made the assumption 35% of the sun's light reflects off the greenhouse, and the rest actually penetrates the greenhouse and hits the plants. It's actually it's a very optimistic amount of light, since that might be true when you first build the greenhouse, but pretty rapidly there's dust, there's dirt, there's residuals from residue from water, and that reduces that efficiency level. Second assumption I make is that the LED efficiency is 1.5 micromoles per joule. In other words, it takes, in order to produce like 1.5 unit light, it takes 1 joule of electricity. So the bigger that number, the more efficient the LED is at converting electricity into photons. And that's actually kind of low for LEDs, for today's LEDs. And just to back up here, so what I'm going to show you in the next slide, what I'm going to try to do is actually try to estimate how many watts of light, by allowing sunlight to come into my greenhouse, how many LEDs can I get rid of, right? How many LEDs does it displace, right? And so that's why these assumptions are important. Now, I'm like the lettuce farm or the lettuce analysis, I'm also assuming that both greenhouse and the indoor farm have the same climate control. So either they both have HVAC or they don't, right? So that way I don't have to worry about the quality of the plant. And finally, the value of the cannabis is $6 per gram. So these are the results. So I did this for different regions, from relatively dark regions to regions with lots of sunlight. So you see in Quebec or British Columbia, there's not a lot of sunlight. compared to other parts of North America. So on average, having a greenhouse in Quebec or BC and allowing sun into the greenhouse, right, is equivalent to having a 150 watt LED light over a 4x4. That's how much light the sun is providing. It allows me to not use 150 watts or reduce the total amount of watts I use to light my plants, light my 4x4 table or 1.5 meter squared table by 100 watts. As I move to sunnier places like Colorado has much more sun than Quebec, now I'm able to remove 300 more watts of LED lights. If I go to a very sunny place like Phoenix, Arizona, you see at the bottom, I can remove 400 watts of light, a much larger bulb I get rid of. And so the value of the light is increasing. Now I used the average commercial electricity price for each of these regions to calculate or estimate the value of that electricity, again, per 4x4 table, per 16-foot square foot table or 1.5 meter square table, which is a typical table size in this industry. So you see in Quebec where energy prices are very low and there's not much light, so the sun is not displacing that much light. The value of the light that I'm getting from the sun is about $2.71 per month per 4x4 table. And that's actually about 30% too high because I forgot to convert that to US dollars. That 271 is actually Canadian dollars, whereas the rest of the table is in US dollars. Whereas if I go to Phoenix, where there's lots of light, so I'm able to remove 400 watts of light from my farm, that's equivalent to reducing my electricity costs by $11.44 per month per 4x4 table. Of course, lights can be expensive. And so I also calculated the monthly cost of owning an LED light. I assume that the LED light costs $2 per watt, which is an expensive horticulture light, and that you pay monthly for this light over 10 years because the expected life span of these lights is about 10 years. So you see that again, by the Quebec light is a relatively inexpensive light. It's about $3.49 per month, whereas a Phoenix light, which is a much larger light, is about $9.32. So the question is, like, for instance, in Phoenix, a very bright place, lots of sunlight, I'm saving about $20 a month in costs related to lighting by having a greenhouse, right? But if we look at that percentage of revenues in terms of how much that costs as a percentage of the revenues created on that 4x4 table, we see that it's very small, right? Ranges from Quebec, which is about 0.2% of revenues, to say Northern California, that very expensive electricity, to about still less than 1% of revenues. So you're giving up control of the environment. And we haven't talked about what's the value of that control yet, but we're giving up some control of the environment because a greenhouse certainly offers less control than an indoor farm. For instance, if I'm in a greenhouse and suddenly clouds come over and block the sunlight, my VPD is going to drop rapidly. If I open spring when it starts getting warm in California or Quebec and growers open their vents and greenhouses, it just sucks out, because it's windy, it sucks out the humidity from the greenhouse and shocks the plants. So there are costs to giving up control compared to indoor farm. And in exchange for those losses in control, you're really just reducing your costs from anywhere from 0.2% of revenues to 0.7% or 0.8% of revenues. And there is strong evidence that, I'll say there's evidence suggests that growing indoors the market does value the increased control provided by growing indoors. For instance, Cannabis Benchmarks is this agency that tracks wholesale cannabis prices across the United States and Canada. And consistently, they find that cannabis grown indoors, the wholesale price of cannabis grown indoors is about 40% higher than cannabis grown in greenhouses. And there's several reasons why that might be, but one explanation is that it's simply better, that the market has determined that cannabis grown indoors, for whatever reason, is higher quality and so worth more money. And I've done my own survey of retailers in Canada and found a very similar result, that in Canada also, cannabis grown indoors is sold for a higher price than cannabis grown in greenhouses. I'd argue that even given the incredible opportunities presented by higher levels of control in an indoor farm, today's growers are rarely taking advantage of it. Indoor growers are leveraging just a fraction of the potential benefits of higher control. I think today they typically use indoor farms to provide more harvest per year and to create a more consistent environment, which from the previous slide, you see that maybe that's provides or generates a lot of value. But the potential benefits go much farther than that. For instance, one of the benefits I think are most important is just the benefits of higher levels of the ability to do more controlled experiments. For instance, because I have a more enclosed environment, an indoor farm, I can have multiple different rooms inside that same indoor farm. I can create different environments. I can essentially do more or less controlled experiments, so I can learn faster about what the optimal conditions are for each plant. Right? And after I learn that information, I can actually customize the environment and maintain the environment for multiple varieties. And as we discussed earlier, we saw for the tomato and flower market, the more varieties there are, the higher the benefits of actually being able to provide those customized environments. And finally, it's a more appropriate environment for developing new hybrids. By being able to control the environment, right? I can not only it's not any more conducive for developing new types of plants, but it also allows me to find plants, look around the world and find plants that don't necessarily grow well in my environment, and create an optimal environment for them here and wherever you're located. So not only is it about developing new hybrids, but it's taking hybrids from different parts of the world, and instead of changing the genetics of the plant, it gives us the ability to change the environment around the plant. And so in other words, it creates options, right? Having a better control of the environment creates options, and people who are familiar with finance, there's something called option value. And so when I have more options, that the optionality generates tremendous amounts of value. Okay. And as we mentioned, the value of being able to learn and customize environments increases with the demand for variety. If there was just one variety demanded by consumers, then the value of learning in customized environments is very low. But if there's lots of varieties, it increases. And the interesting thing about cannabis is there's tremendous amounts of varieties. There's at least 1,000 different cultivars. And the plant has extremely rich chemical profile that we're just starting to understand what the implications of that profile. And an interesting thing about having a plant where the chemical profile is important to the consumer is that small changes in the environment that the plant grows in can have a significant impact on that chemical profile. So it becomes valuable to be able to identify that environment and provide it for the plant. So still, in the last part of this presentation, I want to give you a sense of what, in fact, is the value of control. And so now I want to go back to this original experiment that I alluded to at the beginning of the presentation. And what we did is we asked, well, the easiest thing or the biggest differential between an indoor grower and a greenhouse or an outdoor grower is the fact that indoor growers have more control for lighting, right? They can provide whatever lighting they want. So with 3 partners, Laval University, a cultivator, a greenhouse cannabis, which is this exceptional grower in Canada. They have a great reputation across the country. They won top grower in Canada last year. They were also, a magazine identified them as having the highest strain of producing a strain with the highest THC in the country. So they were an excellent partner to work with. VoltServer is actually an intelligent buildings company. What they do is they provide what's essentially it's called digital electricity. I'm not trying to plug the company. It's just a really interesting innovation. It's basically high voltage electricity you can touch. So once basically you just connect conventional electricity from the street, but then everything inside, all the wiring inside, anyone can do it. You need an electrician because it's literally a new type of electricity that's safe to touch. I won't get into how it's done, but that's a fact. But then the other thing about it is that it simultaneously can transmit data. And so it's been used by intelligent buildings to basically connect everything in their building. So if they want to, like their last installation was for Hilton Hotels, and they enabled the first intelligent hotel in the United States. And what basically they allowed, so basically you walk in and the sensors sense who's in the room. They remember who you are. They remember the lighting adjusts automatically. The music that you like comes on. The water temperature changes automatically. And as you change these things, it remembers. It's basically learning how it's gathering the data to customize the environment for the person in that hotel room. And so they basically provided the analytics and electricity distribution and the lighting as well. They sourced the lighting from this. It's just a floodlight. They sourced a very powerful floodlight from China to help us with this study. And what we did was we went and several of the leading manufacturers of horticulture lights participated as well. And so we took a broad range of lights. I think there were 8 different types of lights, and they all had different intensities and all had different spectrums. And we basically just grew plants under them. And we did it for a long period of time, several harvests. And what we wanted, we're measuring yields and THC. And so you can actually see all this they all have different spectrums. In the back, you can actually see some HPS lights, with HPS and LED. But we also wanted to experiment with levels of light intensity that were much higher than levels of light that are typically provided by horticulture lights, because this was actually the first kind of large lighting experiment done by an academic institution. And so because HPS provides a certain amount of light and everyone's always used HPS, there's no study that suggests that's the proper amount of light. So we went and bought floodlights that provided much more light, so we can see what actually is the optimal amount of light for cannabis plants. And what we found was really dramatic. Basically, on the bottom axis of the graph is light intensity. And on the vertical axis is yields per 4x4, yields per 1.5 meters squared. And if you look at the bottom where you see about 800, that's a ppfd of 800, That's about a typical double-ended HPS light provides about between 800 and 900 ppfd or units of light, let's just say, per 4x4. And you see a big clump of light intensities around that because most LEDs try to provide basically the same amount of light as HPS, but with using less energy. The little bubble at the extreme right of this graph is just a high intensity floodlight, just basically general purpose LED floodlight. It's made for the street. And what this shows you, in that amount of light, it provides about twice the amount of light as, say, an HPS, double-ended HPS. And what this shows you is there's this very strong linear relationship between light intensity and yields, regardless of the light, regardless of the spectrum. I increase light intensity, I increase yields up to twice the amount of light provided by the typical horticulture light. Another thing you see is like all the bubbles are kind of like along that line, which means that the spectrum is not influencing that relationship. In other words, sometimes lights are sold as having a special spectrum and that does wonderful things. But what this shows you is just that in terms of yields, it's just light intensity that matters. And to put things in perspective, we basically, during the course of this experiment, we increase yields per plant by between 30 to 100%, depending on the cultivar, by providing much more light than 99% of the industry provides to their plants. So that's a tremendous amount of money, a tremendous amount of revenue generated by just learning, right? Being able to experiment with lighting and learning the right amount of light to provide to plants. And the reason I'm saying this is that just that intelligent lighting is just one factor. There's so much to learn about. There's irrigation, there's temperature, there's airflow, there's the temperature of the root zone. It just goes on and on. It's like sometimes when I'm doing this research, I'm like, oh my God, I have to check that also. And there's so many things to check. But what the intelligent lighting, this example shows you is that there is tremendous value to learning what is the optimal conditions for the plant, and then manipulating the environment to provide those conditions, right? And what I'm saying is that doing that indoors, right, doing that in a closed environment is much more suitable to do that and efficient to do that in a closed environment than doing that outdoors or in a greenhouse, right? So just to conclude, I'm arguing that there's this tremendous value that's going to be unlocked related to agriculture, that's being enabled by this advent of indoor farms that was enabled by legalization of cannabis. At this point in time, I don't think indoor growers are leveraging that value, but they will, because there's tremendous variety demanded by consumers in the cannabis market, and they want to try something new every week, right? And that variety is going to drive producers to technologies that enable them to supply that variety in the most effective and efficient way possible. So I believe that 5 years from now, we're going to see that the leaders in this market are not necessarily the leaders today, but they're the leaders that are making investment into this intelligent agriculture or intelligent farming today. And what's really exciting is that this is not just for the cannabis market. These technologies and methods that we're going to learn in cannabis market, because the higher margins in cannabis enable those investments, the cost of those technologies and methods is going to be driven down by the scale of the industry, and it's going to make those methods and technology available for other crops like tomatoes, cucumbers, lettuce, whatever. And that's going to fundamentally change controlled agriculture, controlled environment agriculture, growing in controlled environments. And I strongly believe that this is a new revolution in agriculture that we're seeing unfold, and that over the next 5 to 10 years, we're going to see indoor farming initially gradually, but soon rapidly disrupt large proportions of the greenhouse market. So once again, if that was less fluid than you would have liked, it was definitely less fluid than I would have liked. I apologize. As we said this time, so I know that you guys are all compassionate. And I thank you, and I'm be very happy to meet you virtually and to answer your questions. So thanks again for your time, and thank you, Labroots, for the invitation.